So this is just an algorithmic way of putting the same thing. So here's if you remember, in one of the previous lectures I mentioned that every design technique has something called a blueprint or a basic framework. So why this blueprint is important is because when you're given a new problem, if you're able to break down the problem into elements and connect them with the elements of this blueprint, it helps you understand how to implement that problem using this technique. So that's the easiest way to adapt a design technique to suit a problem. So going by that, here is our blueprint for the divide and conquer strategy. So your input is a problem of size n. If your n refers to the base case, which is usually, like I said, 1 unit size array or matrix or whatever, but not necessarily. So if your problem is of the base case, then you simply do the conquer step and return the answer. If it is not the base case, you will divide it into sub-problems. You can divide it into as many sub-problems as you want at each stage. It is not necessarily 2. And the sub-problems are usually of same size but not necessarily. So if you take merge sort, you generally divide an array into 2 halves of equal size. At most, the size difference is at most 1 element. But it is not necessary that is how you have to divide. So depending on the problem statement, depending on what you're asked to do, the number of sub-problems into which you divide your main problem and the size of those individual sub-problems can vary. So anyway, if it is not the base case, what you'll do is you'll divide it into some number of sub-problems. For each of those sub-problems, you will recursively call the divide conquer function and collect the solutions. Finally, you will combine all those solutions as appropriate and return the final combination as the answer.